Assalamu alaikum, dear students. This video is a practice video for functions questions. Before you watch this video, you have to know the concept. So in this video, I will be presuming that you have watched the functions video. If you haven't, I am going to post a link somewhere around the video or in the description below. You can access to the concept video first. Go watch that and then come back to this video. If you have watched the functions concept video, then this video is going to cover the entire worksheet. These questions are going to range from 2004 till 2016, 2018, I think, yeah. So these are all the P1 questions that have come in the past paper questions. So once we are done with this whole worksheet, you guys will be able to do really well in this topic. So let's get started. For question number 1, let's see, this function is given that f of x is equals to x plus 5 over 3, and they are asking you to find f of 1. So f of x is x plus 5 over 3. For those of you who do not know, the function a function has a symbol f of x, or it can also be denoted as this. These two symbols are used alternatively for each other. So now we are required to find f of 1 in the first part. So a part, we are simply going to substitute 1 plus 5 is 6 over 3 is going to be 2. So the first answer is going to be 2. For the second part, it seems like a bit annoying, but it's a very easy part to understand. It says, given also that f inverse of x is cx plus d. Now, see, this cx plus d does confuse you guys, but do not worry about it. We are just going to follow the first part of the instruction, and that is f inverse of x. So let's start with that. We're going to find f inverse of x on our own first. So f of x is x plus 5 over 3. So step 1, replace f of x with y. Y is equals to x plus 5 over 3. 3y, you cross multiply, 3y is equals to x plus 5. I'm trying to make x the subject, so, and x is equals to 3y minus 5. Eventually, you're going to make two replacements, and f inverse of x is equal to 3x minus 5. Now, this is the inverse that we have found, and there was an inverse function that the question told us that f inverse of x would be equal to cx plus d. Now, if you compare these two equations, you can easily find the values of c and d. So we can clearly see from here that c is 3 and d is negative 5. Moving on to question number 2. The first part is quite easy. It says, given that f of x is equals to 3x plus 3, find f of 3. That means go to function f and put x is equals to 3 over here. So let's do that quickly. 3 into 3 is 9. 9 plus 5 is 14. So first part answer is 14. Always remember to mark your answers in the answer space. Let's move to the second part. It says, given that g of 0 is equals to 15. Always remember to roughly apportion your space into 3 columns so that you have more space to work on. So firstly, I'm going to put g of 0 is equals to negative 15. Now we know how to handle these questions. We're going to hide the right hand side. We're going to hide the right hand side of the equation and just follow what the left hand side is requiring us to do. The left hand side says go to function g and put x is equals to 0. So let's go to function g and put x is equals to 0. And this, and once you have done that, remove, unhide the right hand side and put it equal to negative 15. So this is minus 3 into k is negative 15. From here you can evaluate the value of k, that is going to be 5. So this is B2 part. So k is equals to 5. Now for the last part, what we're going to do is g of x is equals to 0. So for the second part, g of x is equal to 0. This is what we have to find. So now we know g of x is 2x minus 3, and x plus, instead of k, I'm going to introduce 5 over here, is equals to 0. Now this question is basically a question from algebra, where we are required to solve a factorized equation. And if you've seen this before, you know that once you have two brackets equal to 0, what you can do is you can put first bracket is equals to 0, and that would give you the first value of x, or you're going to put the second bracket equal to 0. This is equals to x is equals to -5. If you're having trouble understanding this, I'm going to put a link for algebraic solving or factorization or solving videos in the description below. You can go and access to that, and once you've done that, this part will be really simple for you guys. Let's move to question number 3. There is a little bit of misprint, but I'll make sure I'll communicate clearly. So this was supposed to be written as 2x minus 1 over 3. And just to clarify, this misprint isn't in the exam. Actually, when I was making these worksheets in a Adobe editor, this might have happened back then. So find an expression of f for f inverse of x. This is a pretty straightforward question. Put f of x, put y instead of f of x, and then you do 2x minus 1 over 3. What is our second goal? Our second goal in finding inverse is to make x the subject. So cross multiply 3 over here, and let's make 3y is equal to 2x minus 1, and 2x is equal to 3y plus 1, and x is equals to 3y plus 1 divided by 2. So this is the second step. And now last and final step is going to be, please make sure whether it's paper 1 or paper 2, you have to show all the workings precisely. So f inverse of x is equal to 3x plus 1 over 2. You have to make x the subject and then replace two things. Firstly, replace x with f inverse, and then replace y with x. So this is your final answer. So this is 3x plus 1 divided by 2. Do not hesitate to go below this dotted line where you're putting the answers in the answer space. That is perfectly fine. Otherwise, if you're not comfortable doing that, you can write the entire answer above the dotted line as well. That is treated correctly as well. Question number 4. Let's start question number 4. For question number 4, the first part is quite easy. It's requiring you to put -4 in the function. So 3 into -4, -5. So this is -17. All right. For B part, now sometimes it's quite comfortable doing working right in front of the question. Sometimes you need more space. So for part B, I'm going to use the space below. Given that f of t is equal to 10, you have to solve this. Now we remember, what do we do with such equations? We hide the right hand side, we follow the instruction on the left hand side. It is telling us to go to function f and put x is equals to t. So it's 3x minus 5. I know this will become 3t minus 5, and then you unhide that right hand side and copy it as it is. Now we can solve for this. 3t is equals to 15 and t is equals to 5. So this is our value for t. So again, as you can see, I've forgotten to put the final answers in the answer space. Do not do that, and always put your answers in the answer space. It doesn't take much time and it's not worth putting your mark at a risk of whether would they allow that or not. If there is an answer space, you should always fill that for your final answers. Now the third part is requiring f inverse of x. Now, so we're going to follow the procedure, which is a 3-step process. F of x is equals to 3x minus 5. Firstly, replace f of x with y is equal to 3x minus 5. And now I'm going to make x the subject. Y plus 5 is equals to 3x. Make sure that your workings are clear and convincing. Do not try to make jump off steps in between the steps. It's perfectly fine to do an extra step rather than making your examiner confused about whether you reached the final answer yourself or was there any misconduct while you were while you were submitting your answer. So it's always better to be safe. So f inverse of x is equals to, now replace y with x plus 5 over 3. So now this is x plus 5 over 3. We can write like this. Now, the last part, sometimes gives a lot of trouble to many students, but it's quite easy if you understand the basics. It says f inverse of 4. Now, if you read it closely, it is giving you two instructions, and we remember what these two instructions are. First instruction is the name of the function. So it's telling us to go to function f inverse, and the second is the value of input. So this instruction basically tells to go to f inverse function and put the input x is equals to 4. So let's go to function f inverse. We have that function, so that's going to be 4 plus 5 over 3. So again, I'm just going to repeat in this part. This requirement says go to f inverse function, which is over here, and put x value to be 4. So let's put the value of x to be 4 over here. So that's going to be 9 over 3, and the final answer is 3. All right, let's move to question number 5 quickly. Now, the first part is quite easy. Again, it's asking us to put the value of go to function f and put x is equals to 5.5. So 5.5 plus 2, and 2 into 5.5 minus 1. So this will become 7.5, and this will become 11 minus 1. So this is 7.5 into 11 minus 1 is 10. The final answer is going to be 75. All right, for the second part, okay, now this is a little bit of clever question. It's saying g inverse of 5. Now, students generally get confused about such questions because when they start thinking, the question's instruction is saying go to g inverse and put x is equals to 5. Now, the problem we are going to face over here is we do not have g inverse. So I always advise kids in such case to find g inverse over here. There are a couple of other approaches as well, but I think in an exam pressure situation, a student works with this scenario in a better way. But of course, the other ways are perfectly fine as well. So first of all, I'm going to try to find g inverse. I'm going to replace y over here. Y is equals to 1 by 3 times 2x minus 1. 3y is equal to 2x minus 1. And 3y plus 1 is equal to 2x. And x is equals to 3y plus 1 divided by 2. Now, let's see. G inverse of x will be equal to 3x plus 1 divided by 2. Now, we are required to find g inverse of 5. G inverse of 5, and that would be 3 into 5 plus 1 divided by 2. So that's going to be 16 divided by 2, that is 8. All right. Let's move to question number 6. Question number 6 is a bit from is going to use your algebra basics a lot since it's a quadratic equation system. The first one is quite easy. Before I start with the question, let's read an instruction and let's understand what that means. Given that this function is this, find f of minus 2. That is quite easy. That's telling us go to function f, put x is equals to minus 2. That is perfectly fine. Giving you answer in terms of p. Now, these words mean that your final answer is going to contain p in it. Okay, so you will not be able to put any value in place of p. So your final answer is going to contain p. For example, let's do that. So f of minus 2 would be, we're going to function which is x square and put minus 2 at each place where you find x. So over here, if you see closely, I have put x is equals to minus 2 at all the places that we have x. And then you have negative 2 squared would be 4. Whenever you're putting values in an equation, always remember to put brackets while you're substituting values into an equation. So this is 7 plus 4p. This is 7 plus 4p. So f of minus 2 is equals to 7 plus 4p. Now, this is your final answer, 7 plus 4p. The second part requires a little bit of working, so let's do it over here. In fact, we should have done this working over here as well. Okay, so this is A1. Okay, so the question now requires to find the value of p when f of minus 2 is equal to f of 0. Now, for this question, you needed to have a little bit of presence of mind because you had to realize that this is f of minus 2 and this is exactly what we just found in the previous part. So f of minus 2 was 7 plus 4p, and if they're asking f of minus 2 again, you should pick that up and write 7 plus 4p over here on the left hand side. Now the right hand side is also an instruction. It's telling us go to function f and put x is equals to 0. Okay, go to function f and put x is equals to 0. So let's do that. And let's do 0 squared minus 2p into 0 plus 3. And let's solve this equation. This is 7 plus 4p is equal to, everything is going to be 0 except for the 3. And 4p is equals to 7 minus 3 minus 7. 4p is equals to negative 4. And p would be equal to negative 1. So p is negative 1 over here. Now, these are the first two parts. Okay, the third part is going to use your algebra basics quite a lot. Let's understand what I mean by that. Now, they have told us g of y is equals to y squared minus 1. G of y is equals to y squared minus 1. So, we're going to learn how to find g of a minus 1. So, the instruction is quite simple. As you guys can see, it's telling us to go to function g and put a minus 1 instead of this. Okay. Now, what we're going to do is we're going to put a minus 1 instead of y. Now, there's only one mistake I'm going to give you a caution about. Do not try to expand it as a square minus 1 square. That would be absolutely wrong, because if terms are being added or subtracted, we are not allowed to open the power directly. If it was a multiply or divide sign between these, we would be able to expand them directly. So over here, I'm going to use that formula that you guys would know, a square minus 2ab plus b square. So this is going to be a square minus 2ab plus b squared and minus 1. So this will be a squared minus 2a plus 1 minus 1. And this is going to be a squared minus 2a. So this is the most simplified form that we have. If you want to take a common, it's fine. If you don't want to take a common, that is fine as well. It is an equivalent mark. So over here, the only mistake was many students started opening the bracket directly, and they mistakenly expand it as a square minus 1 square, which is absolutely wrong. Okay, let's move to question number 7. It's requiring us to find f of 1 whole 1 by 5. And again, there's a little bit of misprint. Please forgive for that. So f of 1 whole 1 by 5 will be 5 times 1 whole 1 by 5 minus 4 over 3. That is the first step. So let's convert 1 whole 1 by 5 to an improper fraction. So that would be 6 over 5 minus 4 over 3. And let's cancel out 5s over here. And you will have 6 minus 4. And your final answer is going to be 2 upon 3. The second part is quite simple, and you guys will be really comfortable doing that by now. F inverse of x. So firstly, you write the function f of x is equals to 5x minus 4 over 3. Step 1 is to replace y is equals to 5x minus 4 over 3. 3y is equal to 5x minus 4. And 3y plus 4 is equals to 5x. Let's go to another column. So see, if you're making columns along the way, it is really, really helpful. 3y plus 4 over 5. And f inverse of x will be equal to 3x plus 4 over 5. All right, let's move to question number 8. It's a pretty much straightforward question. The first part is simply asking us to go to function f and put x is equals to -9. So 3 minus -9 over 2. So it's going to be 3 plus 9, which is 12 over 2. The answer is going to be 6 for the first part. The second part is quite easy as well. That is inverse of a function f of x is equals to 3 minus x over 2. Now, when we start, first step is replace f of x with y is equals to 3 minus x over 2. Now, there is a technical thing over here. First, I am going to cross multiply 2y is equals to 3 minus x. Now, we know that we have to make x the subject. Now, while making something subject, I always advise my students to keep that term positive. It makes a lot of things easier. You don't have to pay a lot of attention to the signs and everything. So if you're trying to make x subject and it's negative, it's always highly recommended to go to the next other side and make it positive first. So it's going to be 2y plus x is equals to 3. And now make x the subject, and you will be able to write x is equals to 3 minus 2y. And similarly, f inverse of y, f inverse of x is equals to 3 minus 2x. So this is 3 minus 2x. All right, let's go to question number 9. Again, it's a very straightforward question. So the first part is asking us to put -2 into the equation. So this is -10 plus 2 is -8. So this is -8. For inverse, again, go to the simple steps. Step number 1 is y is equals to 5x plus 2. Y minus 2 is equals to 5x. And x is equals to y minus 2 over 5. And you're going to replace x with f inverse and y with x. So this is your final answer. Okay, so this was pretty much straightforward question. I don't think this needs more explanation. Let's move to question number 10. For question number 10, we're going, the first part is really easy. You're going to put 3 into the main equation. So 15 over 6, and with a little bit of critting, 3 5s are 15 and 3 2s are 6. So the answer is 5 by 2. You can also write 2 whole 1 by 2. You can also write 2.5. It's perfectly fine as well. All right. Now for the inverse function, we're going to follow the steps. The first part is y is equals to 4x plus 3 over 2x. Y is equals to 4x plus 3 over 2x. Now, over here, if you have seen the concepts video, we have covered an example over there as well. Always cross multiply in such a condition. So you have 2xy is equal to 4x plus 3. Now bring all x terms to one side. Minus 4x is equal to 3. Make x the subject by taking common 2y minus 4. Over here, many students ask, can you take 2 common as well? The answer is yes, that is perfectly fine as well. But since I'm just trying to make x the subject, I only take x as common. So this is 3 over 2y minus 4. Now, let's move on. Make the 2 substitutions. Okay, let's not waste a lot of time. Okay, so this will become f inverse of x is equal to 3 over. Now replace y with x. This is 2x minus 4. Again, you can have 2 taken common as well. That is an equivalent form to that. All right, now let's move to question number 11. For question number 11, the first part is quite easy. It's requiring us to go to function f and put x is equals to 4 as an input over there. So that's very simple. So this is 12 minus 20, and this will give you -8. This is a pretty straightforward scenario over here. Now, find the value of x for which f of x is equals to 17. Now, we know the trick for such questions is to first hide the right hand side. So I'm just going to hide the right hand side of the equation and look at the left equation. What does it say? F of x. So just go and pick the function f of x as it is, that is 12 minus 5x, and we're just going to remove the we're just going to unhide the right hand side and put it back over here. And now first make x the subject. So 12 is equals to 5x plus 17. What I've done over here is I've brought 5x to a positive side. It gets comfortable for people who are not really used to work with algebra. So I always advise my students who are not really good with algebra to bring the variable to the positive side first and then work with making it the subject. If you're comfortable with the algebra without that, it's perfectly fine. You can use, you can make it subject as you wish, and all of those steps would be correct, I hope. All right. The last part is f inverse of x. F inverse of x, it's quite simple. Again, the step one is to replace f of x with y. Y is equals to 12 minus 5x. Now you have to make x the subject, and again over here you have to focus on the idea that firstly you have to make x a positive term. So y plus 5x is equals to 12, and 5x is equals to 12 minus y. Now if you're going to make x the subject, it's going to become 12 minus y over 5. And now make the two replacements. They're going to be f inverse of x is equal to 12 minus x over 5. Make sure you show all the workings for the examiner to be convinced to give you a mark quickly. Don't make these judgment calls difficult for the examiners by doing less working. It decreases the chance of getting the method mark over here. Let's move to question number 12. For question number 12, we're going to do f of half, which means 4 into half minus 7. So there will be a little bit of cancellation going on. So this is 2 minus 7. This is negative 5. Perfect. Now for the next question, the trick is again to hide the right hand side. So just going to hide the right hand side. Focus on what's written on the left hand side. That's f bracket p. That means go to function f and put p instead in the input. So 4x minus 7 would become 4p minus 7. Now remove and hide the right hand side. Okay, and just copy it down as it is. Now we can figure out 4p is equals to 7 plus p. 3p is equal to 7, and we can see p will be equal to 7 over 3. Please always work in columns so that you have ample space left. Even if you have done the question wrong once, you would be left with a lot of space to work with if you want to do the question again in the same answer space. Let's try question number 13. It's a similar equation to what we have done already. F of negative 2. That means you're going to put negative 2 in place of x. So this is going to be 5 plus 4, which is 9, divided by negative 6. After a little bit of cancellations, you're going to be left with minus 3 over 2. You can write minus 3 over 2. You can write minus 1 whole 1 by 2. You can also write minus 1.5. All of those answers are perfectly fine. Step 1 for f inverse is going to be, for B part, step 1 for f inverse is going to be y is equal to 5 minus 2x over 3x. So replace f of x with y. Now let's closely see what is going to happen over here. This 3x is going to get cross multiplied. 3xy is 5 minus 2x, and then you add 2x to the other side, bringing all the x terms on one side. This is like this, and then you take x common. This is 3y plus 2 is equal to 5. Now to make x subject, this is 5 over 3y plus 2. Now make two substitutions that we always make. The first one is by replacing x with f inverse of x, and then replacing y with x. That will give you 3x plus This is your final answer. So write it in the answer space as well. Perfect. Now let's move to question number 14. This is f of 5, which means you have to put 5 in place of x. Now there are two ways to do this. Some students are really comfortable using a decimal approach. Some students are really comfortable using a fraction approach. Both are fine. It's your choice which one to work with. I'm going to take the decimal form. So 6 minus 5 by 2 is 2.5. So we know the final answer is going to be 3.5. Now, if somebody is using a fraction approach, they will have to make the denominator same, and then they will approach to a final answer of 7/2. The second part is f inverse of x. So I'm just going to write f of x first, so that we can clearly see what is happening. 6 minus x over 2. The first step is going to be replacing y with f of x. So y is equals to 6 minus x over 2. Now, there is a very important thing to notice over here, that since we do not have a single fraction on left hand side, it's not okay to cross multiply right now. You're only allowed to cross multiply a denominator if you have a single denominator, if you have one term on this side, but over in this case we do not have a single denominator because 6 has a denominator of 1. So you cannot cross multiply if you have two denominators on a side. So there are two ways to deal with this. First way is to get an LCM over here. Make the denominator same, like this. Y is equals to 12 minus x over 2. And now it's perfectly okay to cross multiply this 2 over here. 2y is equals to 12 minus x. Now, we're trying to make x subject, remember. Now, while we're making something subject, I've repeatedly said that we want to keep that term on the positive side. So, bring x to the positive side and now make x the subject. Now, x is equals to 12 minus 2y. And last substitutions are f inverse of x is 12 minus 2x. So this is your final answer. This is 12 minus 2x. All right, let's move to question number 15. It has two functions in it. H of x is 2x minus 5. G of x is equals to 3 over x minus 2. The first function is telling us h of 4. This is basically two information. The first information tells us the name of the function, that you have to go to function h. And the second information tells us that we have to put the value x is equals to 4. Let's do that quickly. 2 times 4 is 8 minus 5 would give you a final answer of 3. The second part requires g inverse of x. Now, for the questions where you have more than one function, be careful which function the question is referring to. Many students do mix up in exam pressure, so be careful with that. Now, for g inverse of x, the first step is to replace g inverse of x with y. So it would leave us with 3 over x minus 2. Now, over here, students start getting confused because there's a lot of terms over here. A very simple step is just to cross multiply this. So y times x minus 2 is equal to 3. Let's just simplify a little bit. Multiply y inside the bracket with both of them. So this is xy minus 2y is equals to 3. Now remember, our goal is to make x the subject. To make x the subject, what you have to do is isolate the x term. So this will become 3 plus 2y. And now you can see x is becoming subject if we divide this y over the other side. Now we're almost there. All you have to do is make a couple of substitutions. The first one being replace x with f inverse and replace y with x. So we have y at two places. So we're going to replace all of them. And this is your final answer. And I'm sorry, I made a mistake, I guess. I should not have written f inverse of x. Since the function name is g, so I should have written g inverse of x. Now this is correct. Sometimes they give you the symbol g inverse. Sometimes you have to write it. It's perfectly fine both ways. The third question is quite interesting. It is giving us two instructions. The left side says go to function h and put the value t. Go to function h and put the value t. So over here we go to function h and put value t. So this is 2x minus 5. If I put t over here, this will become 2t minus 5. So if I follow the left hand side instruction, this instruction takes me to 2t minus 5 equal to, now the right hand side instruction tells us go to function g and put x is equals to 3. So we're going to go to function g and I'm going to put 3 over here. So this is going to become 3 over 3 minus 2. 3 over 3 minus 2. And let's solve this equation. This is 2t minus 5 is equal to, we know 3 minus 2 is going to be just 1 and 3 over 1 is 3. Now 2t is 5 plus 3, 8, and it's very easy from here onwards that t is equals to 4. Let's do question number 16. Now f of x is 2x plus 3 over 5x. We have to find f inverse of x. So first of all, you're going to replace y is equals to 2x plus 3 over 5x. Cross multiply this denominator as before. So 5xy is equal to 2x plus 3. Then you have 5xy minus 2x is equal to 3. If you take x subject, this will become 5y minus 2. And if you make x subject, this bracket is going to go to the other side and get divided. All we are left with is a couple of substitutions. So replace f inverse of x with f inverse of x and y with x. So this is 3 over 5x minus 2. I'm sorry, I made a mistake over here. So this is 5x minus 2. All right, let's move to question number 17. Question number 17 is 3 f of negative 3. So if you put 3 plus negative 3 divided by 2, it's just going to become 3 minus 3 over 2. And this will become 0. So final answer is 0. F inverse of x, this is again a very simple one. Y is equals to 3 plus x over 2. And put y is equals, we're just going to make x the subject. So cross multiply this. 2y is equals to x plus 3 or 3 plus x. And x is equals to 2y minus 3. Now once you have that, the final substitutions, f inverse of x is equal to 2x plus 3. So this is 2x plus 3. All right. Let's go to question number 18. Question number 18, the first part is quite simple. It says f of 2. So that means you're just going to put 2. Whenever you're substituting any values in an equation, always use brackets. It's really useful. So this is 24 minus 2 plus 3. Okay, I'm making a lot of errors over here, but now this is fine. So this will be 24 plus 1, which is 25. The second part is also simple. It's requiring to put negative 1 in the function f. So let's do that. So 6 times negative 1 squared minus negative 1 plus 3. So this is 6 times 1, which is 6, plus 1 plus 3, and this would be equal to 10. All right, now for the next part, find f of x is equals to 5. Let's see. Now, again, the trick is to hide the left-hand side, right-hand side, sorry. So just hide the right-hand side and work with the left-hand side. So left-hand side is just simply 6x squared minus x plus 3 equal to, now unhide the right hand side, and that is equal to 5. Now we have to solve this equation. This is going to take just a little bit. So stay with me. 6x squared minus x plus 3 minus 5 is equals to 0. So 6x squared minus x minus 2 is equal to 0. Now, we know this is a 3-term equation, so that means it will get factorized. So 6 times 2 is 12. And if we try to find factors which give us -1, so for factors of 12, we have 3, 1 into 12, 2 into 6, and 3 into 4. And we know that 4 minus 3 gives us 1. But we need -1 as our middle term, so we change the signs. -4 plus 3 is -1. If you have trouble doing this, I would suggest you to go to factorization video and go through it once. You will be really comfortable with these workings from there onwards. So this is going to be 6x squared. 6x squared minus 4x plus 3x minus 2 is equals to 0. Now let's take commons in first two terms and next two terms. In the first two terms, we have 2x common. So this will give us 3x minus 2. And then you have plus 1 common. This is 3x minus 2. For the next part, you have 2x plus 1 times 3x minus 2 equals to 0. And now, once you have two brackets equal to 0, put the first one equal to 0 or the second one equal to 0. Please make sure that your workings are clear and detailed so that the examiner isn't confused to give you a method mark anywhere. Be really careful about that. So -1 by 2 or 2 by 3. All right, now last part is we have to write down and simplify an expression for f of a plus 1. Now, the function was actually 6x squared. The function was 6x squared negative x plus 3. And the requirement that we have for this part is f of a plus 1. This means that you have to go to function x, function of x, f of x, and put x is equals to a plus 1. So this will give you 6 into a plus 1 whole square minus a plus 1 plus 3. Make sure you're putting brackets everywhere while substituting. So wherever there was x, I'm putting a plus 1, but I'm using brackets outside that. Now, again, be careful. Do not try to open this as a square plus 1 square. That would be completely wrong because you're not allowed to open powers directly if there is a plus or a minus sign over here. So how do we deal with this? This is going to be a squared plus 2ab plus b squared. So this is going to be 6 times a squared, which is a squared, plus 2, a is a, b is 1, plus b squared, which is 1 squared, minus a, minus 1, plus 3. So 6 times a squared plus 2a plus 1 minus a minus 1 plus 3. So 6a squared plus 12a plus 6 minus a minus 1 plus 3. So this will give us 6a squared plus 11a, and 6 plus 3 is 9, 9 minus 1 is 8. And this is our final answer. Please make sure to see the instruction says simplify. It doesn't ask you to factorize because many students come to this stage, they're fine, but then they start to try to factorize this as well. But the requirement was never to factorize. So this is your final answer. You can just simply put it there. And secondly, there was another problem. This expression doesn't get factorized as well. So you will get a lot of problem if you're trying to factorize this. All right, so the next question is question number 19. Let's start with this. The first part is really simple. It's asking us for to go up to function f and put x is equals to -2 as an input. So it's pretty simple. Let's put -2 whole cube minus 4. So that's going to be -8. Be careful with the negative sign, and minus 4. This would give you -12. This is your final answer. Do not forget to put your answers in the answering space. Now for f inverse of x, it's going to be very simple again. The first step is y is equals to x cube minus 4. And now we're going to try to make x the subject. So x cube is equals to y plus 4. And now to get rid of the cube sign, we have to take a cube root on the other side. Or you can do an alternate step by taking cube root on both sides. That is equivalent is y plus 4. Now, I would want you guys to just hold on for a second and think about it. Do I need to put a plus minus sign over here? Yes or no? What do you guys think? So, yeah. So for those of you who are thinking, no, we do not need to put a plus minus sign, you guys are right. That is because for a cube root, for an odd root, a cube root, a fifth root, you do not need to put a plus minus sign. But if you're taking an even root, a square root, a fourth root, or a sixth root, we do need to put a plus minus sign over here. Do make a mental note of that. And the last step is going to be, as usual, f inverse of x. We're going to swap the places. For y, we are going to put x plus 4. And this is your final answer. So let's move on to the next part. This is my final answer. Now, g of y is y squared minus 3y plus 1. And you have to figure out what g of a minus 1, a minus 2 would do. It's a pretty simple instruction. It's asking us to go to the function g and put the input as a minus 2. So while putting in the values, I always recommend my students to keep an eye on the brackets. Whenever you're putting in any value, do use brackets for the first step. This avoids any mistakes regarding the signs, the plus minus, so that takes care of itself. A minus 2 plus 1. So in this step, what I've done is I've put a minus 2 over there in the main function. Now to expand, be really careful. The first bracket is going to expand as a square minus 2ab plus b square. And for the rest of it, we are going to stay, I'm going to multiply 3 inside, so it's going to be minus 3a, positive 6 plus 1. And now if you add all of them up, this will become a squared minus 4a plus 4. I'm sorry, I think I skipped a square there. Yeah. And minus 3a plus 7. So gather them up, a squared minus 7a plus 11. And you do not need to go for factorization over here, since it just needs to simplify, asks us to simplify. So this is the most simplified form. It's not going to factorize. Let's move to question number 20. The first question asks for f inverse of x. So the first step is going to be y is equals to x plus 3 divided by 2. 2y is equal to x plus 3. And x is equals to 2y minus 3. Now once we have this, now we have x is equals to 2y minus 3. F inverse of x is equal to 2x minus 3. This is our final answer. Now, question number 20, part 2 is a bit tricky. I've always found a lot of my students struggling on this part. But if you stick to the basics, it's going to be really easy. So I'm going to explain this part in a little bit detail so that you guys are all comfortable with the basic idea. In this part, the question says f of negative 9 plus f of t is equals to a plus bt. Now, I know that whenever you guys see an expression like this, you guys get really confused. So for now, I'm going to ask you to just forget about this side and focus on the left-hand side of the equation. Now, the left-hand side has two instructions. The first instruction says go to function f and put x is equals to negative 9. So let's do that. I'm going to do that in green color. So minus 9 plus 3 divided by 2. So I put negative 9 over there plus f of t. Now, this instruction tells us to go to the function f and put t as an input. So we will get x plus 3 over 2 would become t plus 3 over 2. Now, this is what we have gotten so far from f of minus 9 and f of t. Now, if I were to make this fraction common, since it has it has the same denominator, it will become minus 9 plus 3 plus t plus 3 over 2. Now, if I were to add up all the numbers, minus 9 plus 6 would add up to negative 3 plus t divided by 2. Now, I don't want to keep them like this. I want to split my fraction. So I'm going to write minus 3 over 2 plus t over 2 or 1 over 2t. So what I have done here is I have split this fraction into two parts. It's negative 3 over 2 plus t over 2. Now, so negative 3 over 2 is fine. For 2 over 2, I have written it as 1 over 2t. Now, why have I done this? Because the questions asked me to show my answer in this form. And now, once you're in this form, you can clearly see that by comparing these coefficients, you can get the value of a and b. So a is negative 3 by 2 and b is 1 by 2. So I understand this question is a bit tricky because a's and b's are involved, and you have to put two inputs into the function. But it's very simple if you keep to the basics. So first of all, f of minus 9 means go to the function, put x is equals to minus 9. F of t means go to the function f and put x is equals to t. And let's just keep simplifying this until we get two different terms. And then we compare them with the terms given in the question, and you will be able to figure out a and b. Let's move to question number 21, which is a really simple question. The first part is instructing us to go to the function f and put x is equals to negative 1 by 2. So it's going to be 5 plus 3 times negative 1 by 2. This is 5 minus 3 by 2. And if you want to go for decimals, that's perfectly fine. If you prefer fractions, which I do prefer as in case of paper 1, because you do not have a calculator and students are more comfortable with fractions than they are with decimals in a non-calculator paper. So I'm going for a fraction LCM. So this is 10 minus 3 over 2. So this is going to be 7 over 2. Or 3.5, that is up to you. If you're dealing with decimals, 3.5 is perfectly fine as well. 3 whole 1 by 2 is fine as well, and 7 by 2. As long as the question does not specify which in which form they want a particular answer in, you are independent to give your answers in either decimals or fractions or mixed fractions. Find f inverse of x. Now, for f inverse of x, we're going to put y is equals to 5 plus 3x. Now to make x subject, 3x is equals to y minus 5 and x is equals to y minus 5 over 3. And now for the final substitution, f inverse of x is equal to x minus 5 divided by 3. So this is your final answer, x minus 5 divided by 3. You do not need to worry about whether you place the whole answer above the dotted line, or you can use the dotted line as the middle fraction as well. Let's move to question number 22. For this question, we're going to put f of 4. It means you're going to put x is equals to 4 in the main question, divided by 2 into 4. So this is going to be 7 minus 12 over 8. And this would go to negative 5 over 8. And for f inverse of x, the first step is, as usual, y is equals to 7 minus 3x over 2x. For the first step, we cross multiply. I understand this cross multiplication looks a little bit counterintuitive because the idea is to make x the subject, and this cross multiplication does the opposite. It actually mixes x and y's in one fraction, in one term. But wait for it and just cross multiply for a moment, and you will see that there is a bigger benefit to that. And now, because we want to make x subject over here, we're going to bring all the x terms to one side. So this is 2xy plus 3x is equal to 7. Take x common. This is 2y plus 3 equals to 7. And now you see this x is being multiplied over here with 2y plus 3. We can isolate x by dividing the bracket over to the other side. This will be 2y plus 3. And for the final substitutions, f inverse of x is equal to 7 over 2x plus 3. And this is your final answer. So this is 7 over 2x plus 3. Now let's move to question number 23. For question number 23, the first part is quite straightforward. It requires us to go to function f and put x is equals to negative 1 by 2. Let's do that. Negative 6. And 2 cancels out, and minus 1 minus 6 would give you minus 7. So this is negative 7. F inverse of x, so you're going to put y is equals to 2x minus 6. Y plus 6 is equal to 2x. And x is equals to y plus 6 divided by 2. The final substitution will make this f inverse of x is equal to x plus 6 divided by 2. So this is x plus 6 divided by 2. For question number 4, again, it's a very straightforward question. The first part requires to go for putting a value in the function. So 2 minus 3 times negative 5. So it's going to be 2 plus 15. And this would result in an answer of 17. For f inverse of x, we are going to replace f of x with y in the first step. 2 minus 3x is equal to y. Now the goal is to make x subject. Now for here, you're going to stop for a second and think about it. If we're trying to make a term subject, it's ideal that it is a positive term. So while you're trying to make x subject over here, and you don't want to run into the problems of having different signs than the answers in the marking scheme, although the other answer is correct as well, but sometimes the students are like confused about like, oh, there are different signs in the marking scheme. A better idea is to keep this term positive. So it's negative 3x over here. I would take this to the other side and make it positive. So it will become 3x plus y is equal to 2. 3x is equals to 2 minus y, and x is equals to 2 minus y over 3. The last substitution would give us f inverse of x is equal to 2 minus x over 3. And this is our final answer. All right. Now, let's move to question number 25. For question number 25, you again have to evaluate. So this is a very common theme that we have seen in past 4 or 5 questions, that the questions mainly want to make you do 2 main ideas. First is how to input a value into a function. Second is how to find inverse of a function. So if you are comfortable with these 2 themes, it's going to be a very easy chapter for you. So this is 1 by 2 minus 3. And now again, if many of you guys are comfortable with decimals, so that's perfectly fine. If you're not, go for fractions and take an LCM. You multiply it with 2, and this will become 2 times 1 minus 3 over 1 minus 6 over 2. And this 2 gets cancelled. The answer is negative 5. For f inverse of x, we're going to replace y as f of x. So this will become 2x minus 6. Y plus 6 is equal to 2x. X is equals to y plus 6 over 2. And f inverse of x is equal to x plus 6 divided by 2. There's also a famous, there's also an alternative working to this, and many students are comfortable with that. So I'll do that as well. So y is equals to 2 times x minus 3. So many students would not want to multiply this 2 inside, rather they would want to take this to the other side first. So this will become y over 2 is equal to x minus 3. And now they will make x subject, and that would become y over 2 plus 3. And this is perfectly fine as well. F inverse of x is equal to x over 2 plus 3. Both of these answers are perfectly correct. They're equivalent to each other, so you don't need to worry about either one of them. Now, for question number 26, let's see. So in this question, we're going to just ignore the right-hand side and first fulfill the left-hand side. So go to the function f and put x is equals to 3 minus t. So this will become 5 plus 3 minus t whole squared is equal to 9. So I would isolate this bracket, 3 minus t whole squared 9 minus 5 would give you 4. And now, I would not recommend you to open up this bracket. Rather, it's easier to take a square root on the other side because it's 4. 4 is a perfect square. So I'm going to take square root on both sides. And remember, whenever you're taking a square root to cancel a square, you do need to have a plus minus sign over here. Remember, in a previous question, we also discussed that for a cube root, you don't need to have a plus minus sign, but for a square root, you always do want to have a sign for plus minus. So the square goes away, and you have 3 minus t is equal to plus minus 4. Now, do not, many students get confused with this plus minus sign. There is no need for that. Just split your equation into two parts. It's either 3 minus t is equals to 4, positive 4, or 3 minus t is equal to negative 4. And now this is very comfortable equation solving. So this will be 3 is equals to t plus 4 and t is equals to negative 1. So this is one of the answers. And let's move to the next one. 3 is equals to t minus 4 and t is equals to 7. So there are two answers for this. One is negative 1 or 7. Let's move to question number 27. In question number 27, we're going to have f of minus 2 by 5. So this will be 1 plus 4 into minus 2 by 5. Again, this 4 is going to get multiplied. Be careful. Do not try to multiply 4 with both of the numbers. That is done in matrices and vectors, not in fractions. In fractions, the way this is working is there is a 1 beneath 4 and 1 gets multiplied to the 5 and 4 gets multiplied to the negative 2. So this will be 1 minus 8 over 5. And again, I would rather prefer to be in fractions. Take LCM by multiplying 5. So this will be 5 minus 8 over 5. So this will be negative 3 over 5. All right, for f inverse of x, we're going to have a very simple step. 1 is equals to 1 plus 4x. 4x is equals to y minus 1. X is equals to y minus 1 over 4. And now you have f inverse of x is x minus 1 over 4. So this is x minus 1 over 4. Now for question number 28, let's see what we have. So we have f of minus 3 by 4. F of minus 3 by 4. So go to function f, put minus 3 by 4 over there and see what happens. 2 into negative 3 by 4 minus 9. So let's do some cancellations. 2 times 1, 2 times 2 is 4. So this is negative 3 by 2 minus 9. Again, we are in fractions. Take LCM. It's a pretty common theme in this chapter. So minus 3 minus 18 over 2. So this is negative 21 over 2. Now, f inverse of 3. Now, this is a little bit interesting one. There are a couple of ways of going around it. I'm going to discuss the one which I think students find really easy. So, f of x is equal to 2x minus 9. Let's find f inverse of 3 first. So, y is equals to 2x minus 9. I'm going to find f inverse first. So, y plus 9 is equals to 2x. X is equals to y plus 9 divided by 2. Now, we know that we can find f inverse from here. That would be f inverse of x is x plus 9 divided by 2. Now, the question doesn't require f inverse of x. The question requires f inverse of 3. That means the question requires from us that we put 3 in place of x in f inverse function. So 3 plus 9, 12 over 2 would give you the answer 6. Let's just go through this question once again. This question requires us to go to f inverse and put the value of x as 3. And for that, we first found f inverse of x, and then we went on to put x is equals to 3. Now, for the next question, this is question number 29. All right. So in this question, there is a little bit of understanding required that f of x is usually equivalent to y. So these are the values of x and y that are given in a question. So when x is 1, y is 5, x is 2, y is 7, x is 3, y is 9. There are multiple ways of approaching this question over here. Now, for example, the first way I would recommend is to imagine it as a straight line. Because why is it a straight line? Because it is increasing with equal amount every time. Now, if you want to approach it as a straight line, let's think about it. There are 2 points, 1, 5 and 2, 7. So first of all, I would want a gradient out of it. So gradient would be 7 minus 5 over 2 minus 1. So it would be 2 over 1, which is 2. And then I would want to find the equation of this line, y minus y1 is equals to m times x minus x1. If you do not understand what's happening in this idea, you might need to go through one of my videos regarding coordinate geometry. If you're comfortable with this formula, this is a formula for equation of a straight line. So y minus y1, y1 is 5, is equal to m gradient times x minus x1, where x1 is 1. Y is equals to 2x minus 2 plus 5, and you have y is equals to 2x plus 3. Now, do you guys remember we said y is usually equal to f of x? So this is f of x is equals to 2x plus 3. Another idea how to approach this question was through arithmetic progressions. Now, if some of you would have noticed, this is increasing by 2 every time. So this is if a sequence is increasing by 2 every time, it is a arithmetic progression. So for nth term is a plus n minus 1 times common difference. The first term is 5 plus n minus 1 times the common difference was positive 2. So this will give you 5 plus 2 n minus 2. And this will be 3 plus 2n or 2n plus 3. And now we have to realize that there are no terms. In the place of terms, we have f of x. And there is no n over here. There is x in the upper column. So this is 2x plus 3. So again, both of these methods are different ways of approaching the same problem. If you do not understand the way with the sequences, I think a better idea is to always think about it as a straight line. Now, let's talk about the second part. Function g of x is 8 minus 3x over 2. And now g of negative 2 is required. So what we're going to do is we're going to put 8 minus 3 times negative 2 in the function over 2. So this is 8 plus 6, which is 14 over 2. The final answer is going to be 7. Now, to find g inverse of x, we'll put y is equals to 8 minus 3x over 2. 2y is equals to 8 minus 3x. And now we have to make x the subject. So first making x as a positive term, 3x plus 2y is equal to 8. And now 3x is equals to 8 minus 2y. And now x is the subject, 8 minus 2y over 3. Now the final substitution will become f inverse of x is equal to 8 minus 2x divided by 3. 8 minus 2x divided by 3 is our final answer. Let's move to question number 30. The question number 30 is quite simple. It requires to put x is equals to minus 1 by 2 in the function. So this is 3 minus 1 by 2 over 10. Now, whenever we're dividing with 10, it's a good opportunity to move towards decimals because it would be easier to convert to a decimal. So first of all, I would change the sign. 3 plus 1 over 2 divided by 10. Now 3 plus 1 over 2 is just saying 3 plus 0.5 will become 3.5 over 10. And we know this is going to be 0.35. Now, I usually prefer to stay in terms of fractions, but whenever there is a chance to divide by 10, it is always easier to get to decimals. That is why I chose to go to decimals. But if you're comfortable with dealing with fractions, you can choose to stay in the fractions as well. Now, for the next part, it's asking us for an inverse. No, I'm going to put y is equals to 3 minus x over 10. 10y is equal to 3 minus x. Now, if I'm trying to make x the subject, I must send it to the other side to make it positive first. X plus 10y is equals to 3 and x is equals to 3 minus 10y. Now, for the final substitution, you're going to put f inverse of x is equal to 3 minus 10x. So this is 3 minus 10x. All right. Now, for question number 31, first part is to put 2 whole 1 by 2, which is 2 2s are 4 and plus 1 is negative 5 by 2 into the the formula. So this is 4 plus 3 times negative 5 by 2. So this is 4 minus 15 over 2. And now you take LCM. So this is 8 minus 15 over 2. This would be negative 7 over 2. This is your final answer. And then again, you have to find f inverse of 5. We recently did like 3 or 4 questions back. We did a question like this. So what we have to do is we have to first find f inverse and then put 5 into it. So let's just quickly get into finding the inverse of the function 4 plus 3x. It's not a difficult task, so it wouldn't take long. Y minus 4. X is equals to y minus 4 over 3. And after final substitution, we know that f inverse of x is x minus 4 over 3. Now, if you take up this function, this is f inverse. And we are required to put the value 5 over here. So let's put f inverse of 5 would mean go to function f inverse and put x is equals to 5 minus 4 over 3. And this would give you 1 by 3 as your final answer. Let's move to question number 32. The first part is not really a functions question. It's a simple algebraic solving. If you have single fraction on both sides, your the first step should be to cross multiply. So 6 times x minus 3 is 5 times x plus 1. It's a very simple equation. 6x minus 18 is 5x plus 5. Now, we're going to send numbers on one side and x terms on one side. 6x minus 5x should be 18 plus 5. So x is equals to 23 from here onwards. It's not really a functions question. I think I included this question in this video because of its second part, which relates to the function. So let's move on to that. There are two functions now, function f and function g. The first part requires us to put the value of f is equals to, x is equals to minus 5 in the function f. So let's do that. Minus 5 minus 3 would give us negative 8. Now for the second part, let's see. It's g of m minus 3 is equals to 17. Let's just ignore the right hand side and focus upon the left hand side for now. So go to the function g and put x is equals to m minus 3. So I'm going to the function g and putting m minus 3 whole squared plus 1 and equal to 17 as it is. So all I've done is gone to the function g and instead of x I've put m minus 3. So it was x squared plus 1. Now it's m minus 3 whole squared plus 1. Now, to solve this, I do not recommend that you open this bracket until like it's really necessary. So let's just keep it like this. M minus 3 whole squared would be equal to 16. Now, to get rid of a square, you have to take square root on both sides. And when you take square root, you have to put plus minus sign on the right hand side. And you get rid of the square root. M minus 3 would give you plus minus 4. Now, do not get confused with this plus minus 4 sign. As I told you before, just split it into two different equations. And m minus 3 is equals to negative 4. Now, m would be equal to 3 plus 4. M would be equal to 7. And from here, m would be equal to 3 minus 4. m would be equal to -1. So this is 7 and -1. Okay, for last question, which is question number 23, let's solve f of 11 is equals to 7. Now, for these questions, we have learned to ignore the right-hand sides for the beginning. First, go to the left-hand side and solve this. This requires us to go to function f and put x is equals to 11. So this is 3 into 11 minus k over 4 is equal to 7. So this will be 33 minus k is equal to 28. I would want to send k onto the other side first. So 33 would be k plus 28, and k would be equal to 33 minus 28, and that would give you 5. For the second part, you have to find f inverse of x. To find f inverse of x, you first put y is equals to 3x minus 5, k is 5, over 4, and 4y is equal to 3x minus 5. To make x subject, 3x is equals to 4y plus 5, and x is equals to 4y plus 5 over 3. Now, to find f inverse, you have to do f inverse of x is equal to 4x plus 5 divided by 3. This is your final answer. Now, before finalize this part, there's one thing I need to mention, that if a student has found k incorrectly in the part before, they will not be penalized if they put their value of k over here and solve it as it is. This is called error carry forward. So you will not be able to, you would not be penalized if you have found k wrong. Yes, you would be penalized in the first part, but you would not be penalized in the second part. Now, this is the complete exercise for P1 functions. If you have any troubles in any method that I've explained, you can mention them in the comment section below, and I would be able to help you as much as I could. And if you have liked the way I have solved a question, please do mention that as well. Do share it with your friends and who might need it. And if you like our content, please support our channel by subscribing to our YouTube channel, by following us on Instagram and our Facebook pages, and I'll see you soon in the next topic video. Goodbye.